Assalamu alaikum, brothers and sisters, welcome to the journey of quest where we quench your thirst of knowledge. Did you know that the dramatic peaks and valleys of Yosemite National Park were carved by glaciers? These slow-moving rivers of ice have shaped vast stretches of our planet over millennia. Their relentless movement, driven by gravity and immense weight, sculpts mountains, carves valleys, and leaves behind fascinating geological features. Glaciers form in areas where snow accumulates year after year, exceeding the rate of melting. As the snow compresses under its own weight, it transforms into ice, forming a dense flowing mass. These icy giants move slowly across the landscape, their pace measured in centimeters or meters per year. Imagine the sheer force of a glacier, sometimes thousands of feet thick, grinding its way across bedrock. As glaciers advance, they carve out valleys, deepen existing depressions and transport vast quantities of rock and sediment. Glacial erosion is a two-pronged process, involving both plucking and abrasion. Plucking occurs as the glacier's immense weight fractures the underlying bedrock. The ice then freezes around these loosened fragments, incorporating them into the glacier's base. As the glacier continues its slow march, it carries these entrapped rocks along, effectively plucking them from the Earth's crust. Abrasion, the second mechanism of glacial erosion, is akin to sandpapering on a massive scale. The rocks embedded in the glacier's base act as abrasive tools, grinding against the bedrock as the glacier moves. This process leaves behind distinctive marks on the landscape's smooth, polished surfaces, and parallel grooves known as glacial striations. Glaciers are not just agents of erosion, they are also prolific depositors of sediment. As glaciers melt, they deposit the rock and debris they've accumulated during their journey, creating a variety of landforms known as glacial deposits. One of the most common types of glacial deposits is till. Till is an unsorted mixture of sediment, ranging in size from clay particles to large boulders, that is deposited directly by the melting glacier. It forms a chaotic, jumbled landscape, often characterized by rolling hills and depressions. Outwash is another type of glacial deposit formed by glacial meltwater. Outwash plains, often found in front of glaciers, are characterized by flat, stratified layers of sand and gravel. Moraines and drumlins are among the most distinctive landforms sculpted by glaciers. Moraines are ridges or mounds of till deposited at the edges of a glacier. They form as the glacier pushes sediment ahead of it, like a giant bulldozer, or along its sides, creating lateral moraines. Drumlins, on the other hand, are elongated hills with a streamlined shape resembling an inverted teaspoon. They are composed primarily of till and are thought to be formed by the reworking of existing glacial deposits by subsequent glacial advances. These glacial landforms, moraines and drumlins, often play a significant role in shaping the landscape and influencing human activities. For instance, moraines can act as natural dams, creating lakes and wetlands. Glaciers not only carve and sculpt the land but also leave behind breathtaking bodies of water, glacial lakes and fjords. Glacial lakes form in depressions carved by glacial erosion or behind moraines that act as natural dams. These lakes, often characterized by their crystal-clear water and stunning alpine settings, are a testament to the power of ice to reshape the landscape. Fjords are another striking example of glacial handiwork. These long, narrow inlets with steep sides are formed when glaciers carve out deep valleys that are subsequently flooded by seawater. Found in high-latitude regions, fjords are renowned for their dramatic beauty, with towering cliffs plunging into deep, dark waters. These glacial lakes and fjords, while visually captivating, also hold ecological and economic significance. Glaciers leave behind more than just grand landscapes and bodies of water. They also scatter clues to their passage in the form of erratics and striations. Glacial erratics are boulders or rocks that have been transported by glaciers and deposited in areas where the underlying bedrock is different. These out-of-place rocks, often found perched precariously on hillsides or in the middle of fields, are a testament to the immense power of glaciers to transport material over vast distances. Glacial striations, on the other hand, are scratches or grooves etched into the bedrock by rocks embedded in the base of a glacier. These parallel lines, often found on exposed rock surfaces, provide valuable information about the direction and force of past glacial movement. They are like ancient compass needles pointing towards the source of the ice flow, and revealing the path these frozen giants once took. Studying erratics and striations allows geologists to reconstruct past glacial events, mapping the extent of ice sheets and understanding their impact on the landscape. Glaciers, these massive reservoirs of frozen water, are highly sensitive to changes in temperature and precipitation. As such, they serve as valuable indicators of climate change, their fluctuations reflecting shifts in Earth's delicate climate balance. The study of glaciers and their response to climate change is known as glaciology. Glaciologists monitor various parameters of glaciers, including their size, mass, and movement, to understand how they are responding to changing climatic conditions. One of the most concerning trends observed in recent decades is the widespread retreat of glaciers worldwide. This retreat, driven primarily by rising global temperatures, is a clear indication of a warming planet. The melting of glaciers has significant implications for both the natural environment and human societies. The evidence of glacial retreat is compelling and widespread. From the shrinking ice fields of the Arctic and Antarctic to the disappearing glaciers of the Himalayas and Andes, the story is the same. Glaciers are losing mass at an alarming rate. This retreat is driven by a combination of factors including rising air temperatures, increased melting due to changes in precipitation patterns, and the intrusion of warmer ocean currents. As glaciers melt, they contribute to rising sea levels, posing a significant threat to coastal communities and ecosystems. The loss of glacial ice also disrupts water resources in many parts of the world, as glaciers act as natural reservoirs, releasing meltwater during dry seasons. This disruption can have severe impacts on agriculture, hydropower generation, and human livelihoods. The retreat of glaciers also increases the risk of natural hazards, such as glacial lake outburst floods. The future of glaciers hangs in the balance, their fate intricately linked to the trajectory of future climate change. The Intergovernmental Panel on Climate Change predicts continued glacial retreat throughout the 21st century and beyond, with the rate of loss dependent on future greenhouse gas emissions. Reducing greenhouse gas emissions through a transition to cleaner energy sources, increased energy efficiency, and sustainable land management practices is crucial for mitigating the impacts of climate change on glaciers and the ecosystems they support. Adaptation measures such as developing drought-resistant crops, investing in water storage infrastructure, and relocating vulnerable communities are also essential for coping with the consequences of glacial retreat. Protecting these icy giants and the vital services they provide requires a global commitment to addressing climate change and transitioning towards a more sustainable future. Glaciers, these massive rivers of ice, stand as powerful reminders of Earth's dynamic nature. They are sculptors of landscapes, architects of mountains and valleys, and creators of breathtaking lakes and fjords. Their relentless movement, driven by gravity and the weight of accumulated snow and ice, has shaped vast stretches of our planet over millennia. From the dramatic peaks of the Himalayas to the serene fjords of Norway, glacial landscapes captivate our imagination and offer a glimpse into the immense power of natural forces. But glaciers are more than just scenic wonders. They play a vital role in Earth's climate system, regulating water resources, influencing sea levels, and serving as sensitive indicators of climate change. Their fate, intricately linked to our own, serves as a stark reminder of the urgent need to address climate change and protect the delicate balance of our planet for generations to come. Pause 2S glaciers, these colossal formations of ice, begin their journey in the most unassuming of places, high in the mountains where snow accumulates year after year. As layers of snow compress over time, they transform into dense, crystalline ice. This process, spanning centuries, marks the birth of a glacier. Pause 2S. From the towering peaks of the Andes to the remote expanses of Antarctica, the genesis of glaciers is a testament to the slow yet unstoppable forces of nature. These glaciers, once mere snowflakes, grow into immense ice rivers that carve through rock and earth, shaping the world in their path. Pause 2S. As we marvel at their grandeur, we are reminded of the delicate interplay between temperature, precipitation, and time that gives rise to these icy giants. The birth of a glacier is not just a natural phenomenon, it's a profound narrative of transformation, endurance, and the sublime power of Earth's natural processes. Pause 2S. Glaciers, like all living entities, have a life cycle that begins with their birth and continues through stages of growth, movement, and eventual decline. Pause 2s. As glaciers accumulate mass from snowfall, they grow and advance, carving valleys and shaping landscapes with their immense force. Pause 2s. This relentless movement, driven by gravity and the glacier's own weight, creates spectacular features such as crevasses, seracs, and moraines. Pause 2s. However, glaciers are not eternal. They retreat when the rate of melting surpasses the rate of accumulation, leaving behind barren landscapes and glacial lakes as evidence of their former presence. Pause 2s. The life cycle of a glacier is a dynamic and ever-changing process, reflecting the balance between creation and destruction, growth and decay. Pause 2s. In understanding this cycle, we gain insight into the resilience and fragility of these majestic ice formations and their pivotal role in the Earth's climate system. Pause 2s. Glaciers are not static entities, but rather they are in constant motion, flowing and shifting like slow rivers of ice. Pause 2s. This movement, known as glacial flow, occurs as the immense weight of the ice deforms and stretches under the force of gravity. Pause 2s. The ice at the base of a glacier can melt and refreeze, acting as a lubricant that allows the glacier to slide over bedrock. Pause 2s. This basal slip, combined with internal deformation, propels glaciers forward, often at rates of several meters per year. Pause 2s. The speed and direction of glacial flow are influenced by factors such as the glacier's thickness, the slope of the land, and the underlying geology. Pause 2s. Through this steady movement, glaciers sculpt the landscape, carving out valleys, fjords, and other dramatic landforms. Pause 2s. Observing and understanding glacial flow provides valuable insights into the dynamic processes that shape our planet's surface. Pause 2s. It also highlights the delicate interplay between ice, rock, and water in the ever-changing story of Earth's geology. As our planet warms, glaciers are among the most visible indicators of climate change. Pause 2s. Rising global temperatures are causing glaciers to melt at unprecedented rates, leading to a dramatic loss of ice mass. Pause 2s. This accelerated melting not only contributes to rising sea levels, but also disrupts ecosystems that depend on glacial meltwater. Pause 2s. In many regions, glaciers serve as crucial water sources for rivers and lakes, supporting both human and wildlife populations. Pause 2s. The retreat of glaciers can lead to water shortages, impacting agriculture, hydropower, and drinking water supplies. Pause 2s. Additionally, the loss of glaciers affects local climates, as the reflective ice surfaces give way to darker, heat-absorbing land or water. Pause 2s. This creates feedback loops that can further accelerate warming. Pause 2s. By studying the changes in glacier size and movement, scientists gain valuable insights into the broader impacts of climate change. Pause 2s. These insights are crucial for developing strategies to mitigate and adapt to the ongoing and future effects of a warming world. Pause 2s. Glaciers, once symbols of permanence and stability, now stand as powerful reminders of the pressing need for climate action. Pause 2s. They urge us to reflect on our relationship with the planet and the urgent steps we must take to protect it for future generations. Pause 2s. As we look to the future, the fate of glacial landscapes hangs in the balance. Pause 2s. The choices we make today will determine whether these majestic ice formations will endure or fade into history. Pause 2s. Efforts to reduce greenhouse gas emissions and transition to sustainable energy sources are crucial in slowing the pace of glacial melt. Pause 2s. Innovative technologies and policies that prioritize environmental protection can help preserve these natural wonders for generations to come. Pause 2s. However, the path forward is fraught with challenges. Pause 2s. It requires global cooperation, political will, and individual commitment to make meaningful changes. Pause 2s. By fostering a deeper understanding of the importance of glaciers, we can inspire collective action to safeguard our planet's frozen treasures. Pause 2s. The future of glacial landscapes is not just a scientific concern, but a testament to our shared responsibility as stewards of the Earth. Pause 2s. Together, we can shape a future where glaciers continue to sculpt our world, standing as enduring symbols of nature's resilience and beauty. Pause 2s. Thanks for watching us share our videos. Subscribe our YouTube channel and press the bell icon and stay curious for new uploads.